This is Algebra 2, study guide for test number 4, part 2, picking up on number 19. Solving the equation x equals the square root of negative 3x plus 18, and then identifying any extraneous solutions. First thing you want to do is you want to remove the radical from around the square root. So in order to get rid of the square root of something, you square it. You need to do the same thing on the other side. So what that leaves us with x squared on the left equals, it cancels out that radical on the right, negative 3x plus 18. Then in order to solve this, you want to get x by itself. In fact, it probably doesn't help us to put a line all the way down like that. Move everything onto the same side and set it equal to 0. Since x squared is already positive, let's move everything over here to the left side with it. When negative 3x comes over, it's negative on the right. When it comes over, it becomes positive 3x, or you can just add 3x to where you can see it. And then when positive 18 comes over, you subtract it, it becomes negative 18 on the left. All that together is equal to 0. When you factor out that trinomial, x times x gives you x squared. Your factors of 18 that get you to 3 are 6 and 3. Opposite signs, bigger one's positive. Plus 6 minus 3, both of those are equal to 0. So x plus 6 equals 0. So when you subtract 6, you get x is negative 6. Or x minus 3 equals 0. So when you add 3, you get positive 3. So those are your two answers. Where it says to identify any extraneous solutions, when you plug those values in, if you get something that's not true, it's considered extraneous. So negative 6, if we plug it into the first value, negative 6, equals the square root of negative 3 times negative 6 is positive 18 plus 18. That's going to give negative 3 times negative 6 is going to give us positive 18, so we get negative 6 equals the square root of 36. That's a true statement because the square root of 6 means what? Square root of 36 means what times itself is 36, and it is negative 6, so that one checks out. The other one, when we plug it in, positive 3 equals the square root of negative 3 times 3 plus 18. Negative 3 times 3 is going to be negative 9, and when you put that together with 18, you're going to get the square root of 9. So 3 equals the square root of 9. That's a true statement as well. So both of those are legitimate answers, negative 6 and 3. Solve by finding square roots. You work your order of operations backwards. So before you try to get rid of that squaring something, you divide by 5 on both sides. What that leaves us with is x squared equals 45 divided by 5 is 9. Now get rid of the squaring something by taking a square root. X equals both positive and negative. Remember, both positive and negative. 3, when you multiply it by itself, gives you 9. In order to find the c value, you take b, you divide it by 2, and you square it. So b in this case is 10, divided by 2 is 5, and 5 squared is 25. 22 says complete the square. In order to complete the square, you need to get a new c value. Plus 14 doesn't work. So in order to move it over, you have to subtract it. What that leaves you with is x squared plus 8x plus our new value of c, which we're going to determine, equals, when you subtract 14 on both sides, you get negative 14 on the right. Find your new value of c just like we did on 21. Take 8 divided by 2, you get 4, and square 4, and you'll get positive 16. If you add 16 to the left side of the equation, though, you have to add it to the right side. Negative 14 plus 16 is going to be positive 2. So right now we have x squared plus 8x plus 16. That's a perfect trinomial. We can take the square root of the first x squared term, the a term, and get x, and the square root of c, the 16, and get 4. This is the sign that goes in the middle of them, plus 4. So we have an equation that says, and you square that binomial, we have an equation that says x plus 4 squared is equal to 2. Undo all of this. We're trying to get x by itself ultimately. Undo this squared by taking the square root of it. So if you do that to the left side, you have to do it to the right side. That'll cancel it out and leave you with x plus 4 equals the square root of 2. and then undo x plus 4 by subtracting it on both sides. If you do it there, do it here. You can't take it away from the square root of 2. They're not like terms. So what we have is x equals negative 4 plus or minus the square root of 2. 23 says to rewrite it in vertex form. Your vertex form is y equals x minus h squared plus k. So what we want to do is we need to get rid of this plus 3 value by subtracting it and moving it over. What that leaves us with is y minus 3 equals x squared minus 6x plus c. We need a new value of c. We need to complete the square. Take your b value, 6. It's negative, but it's not going to make a difference when we square it. 6 and divide it by 2 and you get 3. When you square that, you're going to get 9. If you square negative 3, you would still get 9. So that's what I mean. It doesn't matter when you square it. So we get a positive 9 as our new c value. Add 9 to the other side. You can't add it to one without adding it to the other. What that gives you is y plus 6, when you put those two together, equals. Now we want to make a binomial squared out of this. Take the square root of this and we get x. Take the square root of this and we get 3. This is the sign that goes in the middle. So we have almost vertex form. The only thing we have to change is we need y by itself. We need to move that 6 to the other side by subtracting it. If you subtract it there, subtract it from there. You can't take it away from what's inside parentheses. So what you're left with is y equals x minus 3 squared minus 6. This is your vertex form. Remember, that shows you what your vertex is. It's the opposite of that negative 3 for your x value, so it'd be positive 3, and it's exactly what it says on the outside for your y value, negative 6. So positive 3, negative 6 would be your vertex. 24 says to multiply and simplify, if possible. The square root of 20 times the square root of 2. When you put those two together, you get the square root of 40. What perfect square goes into the square root of 40? 2 times 2 is 4 times the square root of 10. The square root of 4 is 2 times the square root of 10. There is no perfect square inside of that. You could have also separated 20 into the square root of 2 times the square root of 10 and put the two square roots of 2 together and got the same result. Then simplifying the complex fraction were the last two problems we had to do. 3 over 5q minus 4 over 4q over 1 over 2q plus 2q. Okay, when they have that fraction bar in the middle, it acts like there is a grouping symbol around the top and around the bottom before you try to do any of the division in the middle. So for the first one, we have 3 over 5q minus 4q. 4 over 4q. Okay, so you have to have like denominators for those. In order to get like denominators for those, you need to make sure you represent q by both of them. Okay. Also, the smallest number that 5 and 4 both go into is the number 20. So 20q and 20q. Now what you're trying to do is you're trying to eliminate those denominators. The q will eliminate the q, and 5 goes into itself 1 time, and it goes into 20 4 times. So you have 4 times 3 for that one, which is 12. Again, the q is going to eliminate the q. 4 goes into itself once, and it goes into 20 5 times. So you have negative 4 times 5, which is negative 20. So the top of the fraction, what we have in parentheses in red right here, is going to give us 12 minus 20, which is negative 8. You have to take that and put it back over the denominator that you came up with, though. Negative 8 is going to go over 20q is what they had in common. And you can simplify this. The number 4 goes into both of these. It goes into negative 8, negative 2 times, and it goes into 20 10 times. So we got a lot of work to do with that beginning to get negative 2 over 10q. Now that's going to be divided by what we're going to simplify in the blue part. 1 over 2q plus 2 over q. You got to make sure in order to simplify this, they have to have the same denominator. You have to have q represented, and you got to make sure you have 2 represented. So for the first one, 2 is going to cancel out 2, and q will cancel out q. So you have 1 there. Q is going to cancel out q for the second one. You multiply 2 times 2 to get plus 4. So for the second one, we have 1 plus 4, which is 5. But again, just like the other one, it has to go back over the denominator you said was the same for both of them, which was 2q. Unlike the red one, though, we can't simplify those. So we have negative 2 over 10q divided by 5 over 2q. Now, anytime you are dividing fractions, you want to leave the first fraction alone, negative 2 over 10q, and you want to change division into multiplication and multiply by the reciprocal. 2q goes on top, and 5 goes on the bottom. So remember, you can always cancel out anything that's the same at both the top, on both the top and the bottom. The variable q over q will cancel itself out. And then you can multiply straight across and then simplify it after if you feel better doing that. Negative 2 times 2 is negative 4. 10 times 5 is 50. The number 2 goes into both of these. It goes into this one negative 2 times, and into this one 25 times. So this simplifies to negative 2 over 25. All that mess right there is negative 2 over 25. We're going to do the same thing with the other one. Not quite as long of a problem as the other one, but they're still going to be separated. The top and the bottom don't really have to. You don't have to do the top for this one. You're going to take that 4 over x plus 3, and you're going to divide what we're going to simplify right here, 1 over x plus 3. Now, in order to add 1 over x plus 3, you have to make sure they have like denominators. So you have to multiply both of them times x. When you do that to this one, it'll cancel out and leave you with 1. When you do it to this one, it's plus 3x. The like denominators, though, all of that is going to be over x. So we have with the other one, when we bring it down, 4 over x plus 3 is divided by that 1 plus 3x over x. Leave your first fraction alone, 4 over x plus 3. Change division to multiplication and flip it to make it say x over 1 plus 3x. Now multiply straight across with these. 4 times x is 4x. And then you have 2 binomials you multiply here, 1 plus 3x and x plus 3. And it's not going to simplify any further that way, so leave it simply as x plus 3 times 1 plus 3x. And there's a simplified version of number 25, I believe, 26.